So what I want to talk to you guys about today is HTML5 mobile. In particular, performance tuning, even more specific regarding hardware acceleration. And currently, a little bit, oops, that's a duplicate slide. A little bit about myself. I'm currently building a company called ChefMade. It's based in Chicago. So hopefully at some point we'll come to Boston, but essentially what we're doing is delivering meals like this. You can't really see it because the projector's not very good, but these are delicious. And what we do is we deliver them on a weekly basis to your fridge. You get a chef-prepared meal that's pretty nutritious. It gets put in your fridge for the week. You can take it out, put it in the oven when you're ready to eat it, or bring it to work. It's a better way of eating healthier. Without all the hassle of cooking yourself. But previously I was at a company called Belly. You guys might have heard of that. Anybody use Belly? A couple of you guys. So we're in Boston in several stores throughout, but we're headquartered in Chicago, where I was there for about 3 years. 6 months ago I left to pursue ChefMade. But if you don't know what Belly is, essentially what it is a loyalty platform. We install iPad apps like this in stores. You can go in, you can check in using one QR code throughout any of the merchants that we have, and you earn points. And eventually those points earn you rewards, whether or not that be a free cupcake or a punch in the stomach. That's real. But the iPad app that we install is sort of a portal for us between the merchant and the user. So we really wanted to put a lot of care into that. And so one of the things that we did was we decided to build a hybrid application. And I'll go over why in a second. But we have a really good engineering team, all really talented guys. And we had I'm going to go back and forth with saying we have and had because I'm not there anymore and I'm confused. But we have really good talent both on the Android side and the native iOS side. So it wasn't a matter of we just didn't have the guys. We actually had really good talent. So and we love cutting edge technology as much as the next hipster, but we do feel like we make smart decisions when it comes to technology. So hybrid certainly, or HTML5 and a hybrid app certainly didn't seem to make sense, but it ended up actually transforming our business. So are you ready for that? I'll tell you a little bit about it. So around the time that we actually decided to rewrite the application, it was originally a native application. Both Facebook and LinkedIn both had hybrid applications. But as we started development, they both said it wasn't ready, and they backed out, and they converted their app back to native. So it was a little bit daunting for us. In fact, Mark Zuckerberg, guys, it's not Mark Zuckerberg. Anyway, he said the biggest mistake he made as a company was HTML5. That was obviously taken out of context. Can you not see that other one? Oh, no wonder. It's funny when you can see it. So that was obviously taken out of context, but it was very true. I mean, HTML5 wasn't ready, and especially for a company like Facebook. But we said, hell, let's try. So the biggest problem we were having, and the reason why we decided we needed to do this, because deploying took an extreme amount of time and money. And at that time, we actually had launched our second market, which was Austin, outside of Chicago, and we had just deployed probably 100 iPads through the city of Austin, and all of a sudden, all of the iPads started crashing. And so what we realized is there was a bug in the system. This was the native code, and what we had to do is go individually to each of those iPads and update them ourselves. Not only could we not expect the merchants to update them, because most of the time, it was an employee that didn't really care. Or the decision maker, which we call them, or the store owner wasn't there, or wasn't there very often, and getting them to care about updating the actual iPad application wasn't very easy. So we would actually have to go into the stores and update ourselves. But then we actually started locking them down because employees were downloading Angry Birds and Candy Crush, or even Yo. I'm kidding, that wasn't even around. But So we knew we had to lock it down and ensure that our members were getting a consistent experience, and the iPad wasn't sitting there with Angry Birds on it when they came in. So innovation slowed. I mean, we couldn't just keep going into all of these stores to update the iPad every time we wanted to test a feature. And again, this was like 3 years ago, so there was no capability of actually doing that without going through the App Store and forcing them to update. So bugs could kill all activities, and we had an instance in Austin where it actually did. So not only did we go and build a hybrid application, but I want to emphasize that the fact that the entire application, if you've ever used it, it's pretty slick. The whole thing was HTML5 within a web view. It was a hybrid, but there wasn't like web views within the native application. It was the actual interaction were all HTML5, except for this one screen, which was a scanner, which of course you can't do that in a purely HTML5 web view. So what we did was we built a plugin so that we could control the camera and place it right on top of the web view. But the JavaScript had full control over that. So the code base looked a little bit like this. We used the Backbone at the time. That was sort of the clear winner. This was pre-Angular and all that. Of course, Backbone is very limited, so we built a custom framework on top of that, which we called Dogbone, which kind of helped us lay things out, componentize things, a lot like Angular, similar paradigm. We used PhoneGap. We thought it was a quick and easy way to get going. It's got a really good plugin architecture. The Cordova aspect of it was important. And then we built what we call a bootloader. And that was probably the coolest part of the system, which allowed us to push new versions of the application whenever we wanted. We could push it to any iPad that we wanted. We could pick iPads. We could categorize iPads. And we could push new versions of the application whenever we desired. It was very, very easy to push the JavaScript, HTML, and CSS of the application. And if we wanted to up the native application, we had a little trick up our sleeve for that too. But of course, since then, there's been a lot of this is all off because the thing's too high. But there's been a lot of innovation, a lot of companies moving forward on HTML5, and since there's been a lot of really great tools. But back then we sort of had to, and we were forced to strip everything down to its core and kind of learn what was going on behind the scenes in order to get the most performance out of it. And I'll show you a demo of the iPad at the end, and you'll see how sort of smooth it is and native-like it is. So one of the things that I want to kind of focus on is the browser, and particularly the browser's rendering engine, and the sort of process there and how it utilizes the GPU. You've probably gotten a little bit of a basic idea before of how a browser sort of utilizes its rendering engine. It'll parse the HTML, create a render tree, which is the actual visual representation of all of the styles. It's the definition of it, and then it'll lay it out depending on the z-index and the positioning on the screen. And then it'll actually paint it to a bitmap, and that bitmap gets drawn to the screen. Each browser, of course, is different, and there's no real clear indication of how each one of them works. There is an article that I suggest you read if you're interested in this, which is at HTML5 Rocks. Just search how browsers work. It's a really good overview of some basic things about how the browser works. But of course, it's kind of a trial and error thing. You don't really know what's going on, and the browsers aren't really speaking up about this too much. Chrome is really making a push for this, but it's a lot. There's a lot going on behind the scenes, and they don't always want you knowing what happens behind the scenes, because the whole point of the web is abstracting this stuff and making it very easy. So understanding the difference between the CPU and the GPU is really important when it comes to hardware acceleration and understanding how to get the most out of your browser's rendering engine. Mythbusters actually did a really neat little demonstration. I don't know if you've seen this, but it's I don't have audio, but you don't really need it. it's basically this like representation of the difference between a CPU and a GPU, and this would be the CPU. And as you can see, it's all happening sequentially, and each pixel is being drawn drawn each point at a time. And it's very slow and it's not very intelligent. It's just a smiley face that it's creating. But then they created this giant monster, and it's pretty accurate when it comes to comparing it to a GPU, because a GPU is anything but efficient when it comes to the actual part itself. But what it can do itself is quite quite powerful. And so they created this giant paintball machine, essentially, to represent what a GPU would be like. And so I think this is the video. Here we go. So everything's happening in parallel. It's painting or it's drawing the entire thing at once. This is the Mona Lisa. It's hard to see on the screen. But very quickly, you see the GPU is much more efficient. It's pretty cool. But what's important to understand is the sort of difference between painting and drawing. We talk about this a lot, but it's very often miscued. The painting process is more the strenuous process on the CPU, which will actually create the visual representation. It'll create a bitmap of what that content is. So whether or not you're using a text shadow or a gradient, your CPU is creating that image, that bitmap. And the drawing is the actual casting the representation onto the screen. So when you see it on your screen, that's the drawing process. The drawing process is extremely fast. You can't tell the difference. If you're just doing a drawing process, particularly on this GPU, it's a very, very quick, efficient calculation. So if we can stick to as much of the drawing and as little of the painting, the better the application. So essentially, this is kind of like the life cycle of painting and then drawing. The CPU will paint the bitmap, and either that CPU will then draw it to the screen, or it'll upload it to the GPU for the GPU to draw it to the screen. The boxes in red are very sort of strenuous processes on the machine. The upload in particular. So this is necessary. We always have to do paints, but limiting paints is good. The upload is good if you can utilize the GPU's drawing capability, because that is uber fast. But we can also draw using the CPU, so it's not necessary all the time to go to the GPU. So here's a bit of a demonstration between elements that have been hardware accelerated, and then ones that have not. You can see this is very smooth, but if you look at the top, it's quite jaggedy. And this is what we're kind of used to with the jQuery days of jQuery animations and non-hardware accelerated animations. But the bottom is very native-like, the top is very old school. You can see it a little bit closer. It's quite obvious. But one of the key things to being able to do this is something called understanding the Graphicsconv, or backing stores, or you might hear layers. And what the browser is doing is essentially creating multiple bitmaps that it can then manipulate later. And it will do so without disturbing the rest of the browser. Traditionally, in a browser, what would happen is anytime anything on the screen changed within the style component at all, if the color changed, the text changed, if the layout changed in any way, the entire screen would have to be repainted and redrawn to the screen. It was very strenuous. Even scrolling could be strenuous. But so as we added graphics and animations and all that, being able to do that was very difficult. But not only that, but if we were doing animations, if we wanted 60 frames per second, for the browser to actually repaint that 60 frames in 1 second is quite difficult. So that's why we're starting to see the GPU being utilized for animations. It's not best, or it's not just great for animations. I'll show you some other tricks of using the GPU for things outside of the animations, but you see it talked a lot about within this sort of animation context, because there's a focus on that for one. That's where you get the most performance, especially on desktop. And it's a little bit wonky to use it for anything else, but I'll show you how we were able to do that. So Safari is one of my favorite tools to actually debug this, because they actually give you something called the Layers tab, or sort of an overview of each layer that they're using. But to start sort of viewing this, you can open up your debug panel and select Show Compositing Borders. This will start to highlight the compositing layers. These are the different layers. There's also tiles. So in both Chrome and Safari, you'll see when you enable this setting, you'll start to see little boxes around everything, and then bigger boxes around everything else. Chrome's a little bit better about the actual paint, or the actual boxing like this. But Safari is nice because you get numbers next to everything, and that's the actual number of times it's been painted. So again, painting is a very strenuous process, so keeping that low is in your benefit. So I already went over that. So this is the Layers tab in Safari. This will actually give you each of the different layers that the GPU or the browser is creating. These are the different graphics contexts, or the backing stores. It'll also, if you click on it, give you different reasons for compositing it. Sometimes it's not obvious, sometimes it's not your intention, but it will composite it. For example, element establishes a stacking context. That's usually because, I mean, it's animated, but you'll see some elements are created simply just because they're within the context of another composited layer, or something's animating over it, and the browser decides that it's actually best to be composited. But Safari is really neat because you can see all these things, and you can see the number of paints, and you can see the number of memory it's using, which you'll see that one's 11 megabytes, which is quite a bit. But the bigger the bigger the composited layer, the more memory it'll use. And this is one of the reasons why you don't want to use hardware acceleration for everything. If we could, it would actually be quite efficient. Despite the actual process, there are instances where it wouldn't be, but in order to have like everything as separate composited layers, it would take a lot of memory, and that's one of the main reasons why you don't want to do it with everything. But also I'll show you an example of something that actually slowed it down and created a lot of paints by using I think I have an example. We'll see. But there are reasons why you wouldn't want to use hardware acceleration, because that upload process from the CPU to the GPU is quite slow. So if you have to do that every frame, then it's actually going to be very slow. So this is an example of a non-hardware accelerated animation. The one that we saw before, you'll see that it's blinking really fast. That's because it's being painted for every frame. And Chrome's really nice about sort of making that very obvious. If you zoom in, you'll see there's like a varying sort of measurement of the frames per second. At one point, if you keep watching, it drops down to about 18 frames per second. But that inconsistency is what's making that very sort of jaggedy feel to it. To add hardware acceleration to this, and you guys have probably seen this, it's very, very easy. There's other properties that'll do it. It's not a standard by any means, so browsers can change this. It's certainly hacky, and there are standards coming, but it's still something that if you're going to build an HTML5 mobile application, you kind of just have to be hacky. It's kind of part of the job description. So to enable it, what we're doing is adding it to the background and loading. This is triggering hardware acceleration just because the browser knows that Translate 3D is something that benefits from having the hardware accelerated by using hardware acceleration, by using the GPU. So it'll create its own composite layer. You'll see here, the background itself is compositive, there's a border around it, and then the spinning dog loader is a composited layer itself. And that skip right there is just the video replaying. But these little tiny borders that are kind of moving past each other, those are tiles. And tiles are essentially just breaking it up into smaller components so that if a layer is arbitrarily large, or if it can be arbitrarily large, so if it's a million pixels wide, the browser is going to break that down so that it's not trying to repaint that whole million pixel wide bitmap. It's just going to start repainting that's actually in the viewport. It's much more efficient.
So it's just that one style property you said in
yeah. Yes. So because Chrome looks at that property as a reason to hardware accelerate that whatever that element is, to composite that element, it's creating the composited layers here. And so the animation that we're using is using some kind of transform property. And so there's only a couple properties that will actually animate and use the GPU. So the GPU is capable of doing that. It's usually opacities, transforms, or filters. And there's more coming. The browsers are trying to incorporate more. But you sort of want to avoid, if you're using animations, some of the properties that the GPU can't handle, which is like top property if you're animating the margin or padding. That's going to have to repaint every pixel no matter what. And if you add hardware acceleration to it, you're going to be doing that GPU upload every single frame as well. So it's going to be adding a lot of time to it. If you zoom in, you see it's a consistent 60 frames per second. It's very smooth. And this is because all we're doing, this entire process, is just redrawing. It's not repainting. The bitmaps are there, they exist. They're uploaded to the GPU, and the GPU knows how to handle it. Another really neat thing that we used with the GPU and compositing is what we call caching. And that was, we would render bitmaps, create images or elements, create a composite layer out of it, and then move it off the screen. And so it'll actually, the browser will go through the process of rendering it to a bitmap, but you won't actually see it on the screen itself, and it'll store it in memory. And it'll upload it to the GPU, cache that bitmap, and when we want one of those components, all we do is translate it back onto the screen. So using something like Translate 3D, you can actually put it back on the screen wherever you want. Usually I'd have a property that was like, it would have translate 000, and then I have a class that's like hide, and that class would add negative some odd pixels using Translate 3D to move it off the screen. That would ensure that bitmap is continually cached, it stays in memory, but it's moved off of screen so that when you want it, all you have to do is redraw. Does that make sense? It's very, very quick. Those are all the elements that we were caching there. So here's an instance of a view that we had that was literally repainting more like some odd times a second. And it didn't even matter if it was on the screen or not. The browser was repainting that bitmap. It wasn't redrawing it to the screen, but it was repainting it. It was sort of uploading that, or it was recreating that bitmap. All it turned out to be was this little cursor. And so this cursor is actually an HTML5 element, or it's animating with CSS. The whole keyboard is also HTML. And that's a long story in itself, but we decided to rebuild the entire keyboard and the functionality of it because it actually worked better for us. The number one reason being we could, well, besides being able to customize it and other things, and it was very quick, we weren't able to pop up the keyboard due to typical bug. Well, it wasn't really a bug, but it was a feature in Safari where you can't trigger the keyboard unless you actually have a user event. Somebody taps the screen, and that's to prevent web pages from saying, focus on my search input, and the keyboard would pop up as soon as you browse to that page when you don't actually want the keyboard. It's just a convenience factor on the desktop, but an annoyance on mobile. So we weren't actually able to do that. I think you can set it now to do that, but at the time, that wasn't possible. So we built our own keyboard, and it was very quick, very efficient, but this one little bugger was constantly repainting, and that video that you saw before, it was actually repainting the entire screen. It wasn't just repainting that little area, it was repainting like this entire view. So it was very slow, and you'll see in the next screen what we did here. Well, sorry, so this is what we ended up doing with this particular cursor was, instead of animating it with the RGBA property, which was repainting it every time, we added hardware acceleration, and we just animated the opacity. That's, again, just redrawing and not repainting. With the keyboard itself, we had some issues with it actually triggering the input value right away, because there was, when you clicked it, you'd have a on state. That on state would repaint that whole keyboard until we started hardware accelerating it, which would create composites, so that was just repainting that one little keyboard. The other benefit of a composited layer is that if you do repaint it, it's not repainting anything else, it's just repainting that one bitmap. And you'll see the difference with this keyboard. There's two things to notice here. I know it's kind of hard to see, but the left portion of it, you see how it kind of blocks in? That's because we weren't caching at that point, and the whole thing was being repainted. If you translate it off the screen, so you paint it once, translate it off the screen, and when you need it, like the right hand does, it just translates it back on the screen, which is just redrawing it onto the screen. Very, very quick. The other thing to notice is when you tap, one of the taps on the left are very slow. They're kind of got a little bit of a delay, and that affects the actual process of putting it into the input up top, the HTML5 input that we built. And on the right, it's not, and that's because, of course, the drawing process, or that whole repainting process, is blocking, so nothing else in the browser can happen in the meantime. So there's many reasons for compositing. That says reasons for compositing. This is Chrome's explanation, and there's more to it, but this is sort of their overview of what is composited. Some of it's pretty obvious. You know, layer has 3D or perspective transform. That's any of the transform properties. Video or canvas elements can be hardware accelerated. CSS animations, filter properties. The last two are pretty interesting. So layers with the composited descendant has information that needs to be into the composite layer tree. This is basically, so these two are kind of talking about like dealing with other elements or different types, where you're compositing it based on other reasons and how it interacts with other elements. So that's why the Safari tool that I showed you earlier with the layers and understanding what you're actually compositing is important, because you can get an idea of what the browser is actually, you know, if you're creating composite layers that you weren't expecting, and maybe very, very large composite layers, which is adding to your memory. Some general overview of the tips that we kind of went over. I'd keep composite layers small, if possible. It doesn't have to be all small, but certainly we use large ones. But the larger it is, the more memory it takes. Composite elements that are updated often. This is like the keyboard, for example. Every time you click that keyboard, it's going to repaint. And there, you could get creative and actually have an element that just kind of comes in and hides or shows underneath it, so you don't have to actually repaint at all. But the benefit of doing that is it repaints quite fast. We're compositing it so it's not affecting the rest of it. Compositing layer off screen allows you to pre-buffer or pre-render those elements. You can cache them for later use and then just quickly draw them to the screen. Avoid several texture uploads. That's the whole process from the CPU painting to the bitmap and then uploading to the GPU. If you're doing that every single frame of an animation, it's going to be very slow. So it might actually be better to go with just the CPU and don't composite that. because it'll be much faster without having to do that process. And then of course use Chrome and Safari or any others that might have come up over the last 6 months that I haven't really seen, but that are really useful for monitoring compositing and hardware acceleration. The feature is a property called will change. I don't actually know where it's at in its current state, but at the time when I originally started talking about this, it was just sort of in draft and they were talking about it. But essentially that would be the replacement for the hacky translate 3D property that we talked about earlier that triggered hardware acceleration. And there are other elements that do that now, but they're all just elements that are kind of, you know, you're not supposed to use them for this purpose. You're supposed to just use them to actually animate. But this will be a purposeful way of saying to the browser that this property is going to change or animate in a way that makes sense for the browser to consider compositing it. So this is a little demo of the iPad app that we built. There's a bunch of animations on the home screen. It's changed since, so if you see it again, it's not the same home screen, but this is a very sort of, you know, all of these elements are essentially composited. We needed to do a lot of compositing here to do these animations smoothly. But you'll see the whole thing is very quick, smooth, feels native. All it is just CSS animations. And then when you interact with it, in general, the screens render quite quickly. Most of it's cached, so it doesn't have to re-render it. The only thing it's waiting for is data from the server or data that's cached locally, depending on what request it is. But as you can see, I mean, it just feels like any other application. This is the keyboard that we talked about. It's quick. And that's it. Any questions? No questions?
So React has the same idea of, you know, trying to do repaints. Is that similar, like conceptually, like to what you?
So I don't know that much about the React Native, you said? Because well, is it React or just React? React Native is a new thing. I'm not entirely sure. I'm not familiar enough with even React, but React Native. I have heard talk about them utilizing it. I'm sure they are. I know Ionic is utilizing it. I'm sure most of these frameworks are you know, implementing it for you, trying to abstract some of this. It's a little bit more. It's tough. You know, it's not necessarily as easy as using a framework. Framework's not going to take care of it for you. So I think having a general understanding of it is good, so you can work with it. But yeah, I think they're like React and other frameworks are trying to use hardware acceleration to create that very sort of performant interactions.
Are there any good tools to measure improvements when you're like working on this to tell whether it actually got better? Like you showed the page counts, but it's hard to tell did I get better or worse.
Right. Honestly, like I think for the most part, what I did was just like played with it a lot. I know it sounds kind of stupid to say that, but it's just you know, there's not a lot of tooling out there. I think, you know, there are some maybe tools that have come about. I've heard about a couple. I haven't used any that I love outside of like Chrome and Safari. And even then, it's not even, you know, it's not your mobile device, so you can't really understand what's going on there. You can remote debug with Safari, but you don't actually get these capabilities, or at least you didn't when I was doing it. When it came to hardware acceleration, honestly, like you can really tell the difference. The only big concern is memory usage. So you can get to the point where you're using too much compositing and your application is starting to crash because you've got way too many cached bitmaps. But yeah, trial and error. It's my favorite tool. Yeah.
Did you do any metrics on battery life?
So not really, because we were lucky in that regard. Our iPads are locked down with the. I mean, that's not to say people did unplug it and use it to charge their phone, but it wasn't a big enough problem that we analyzed it. But I do, if you're using a lot, you know, especially with constant animations like that, it certainly will drain the battery, but I don't know at what rate. Anybody else? Thanks, guys.